All right, guys, so let's go over some pretty basic fundamental ideas you need to know about logs. If you just say, hey, you have a log, you don't know what the base is. So right here, you just have a basic generic log. It's log base b of a equals c. This double arrow, it's an if and only if statement, means it has to be a two-way street. So whatever I write over here, this must be true going this way, and this has to be true going this way. If I say it's a natural log, that's really log base e, which is actually going to equal ln. That's actually a button on your calculator. If I say common log, it's log base 10, but we just write it as log. So if there's no number written for the base, it's understood to be 10. We also have a change of base formula here. It says log base b of a equals log base c of a divided by log base c of b. It looks pretty complicated, but the way I actually remember this is a little easy saying my outer number over my inner number, because if you look at over here, my a is actually the outer number, my b is my inner number. So I have my outer number over my inner number. Now that c can actually be really any base you want, but the only reason why you would really do change of base is so you can put it into a calculator or look it up on a table, which more often than not, it's either going to be a natural log or a common log. So you'd really want to let your c to be e or 10. And as we talked about before, e is Euler's constant, which is approximately 2.71. Now, let's just kind of look right here. And in class, I showed you a little trick, a little visual aid to kind of remember the formal definition of a log. If we circle my base b, we can draw a scorpion tail all the way around to c, because this means that a equals b to the power of c. So your base b here is going to follow the scorpion tail all the way down to the bottom of c, making c the exponent. So I'll ask you problems like log base 4 of 64 equals 3, and I want you to write it in exponential form. Well, pretty straightforward. You can do the scorpion tail trick. So this was going to be 64 equals my base 4. It went all the way down and 3 was on top to the third power. Or we can do log base 9 of 59,049 equals 5. Same thing, scorpion tail. Circle your base. Draw your little scorpion tail here. And now we have 59,049 equals 5. Oh, does not. Equals 9 to the fifth power. So that's pretty straightforward. If I give you a logarithm and ask you to write it in exponential form, you just simply do the scorpion tail. And of course, you could always undo this process. We could circle my 4 and go backwards, kind of making like a little spiral, and this would become log base 4 of 64 equals 3. So you can go both directions. And this becomes log base 9 of 59,049 equals 9 to the fifth power. Wow, not paying attention here. Equals 5. There we go. All right. The other type of problem I want to ask you to do is to solve with using change of base. Now, we don't have the calculators that will do different bases because you know my feelings about having graphing calculators. We can do pre-cal with just a regular scientific calculator, and that's what we do. So, here we go. I'm going to ask you to solve log base 3 of 19,683. The way you actually do that is we're going to take our outer number over our inner number. I'm going to write my change of base in both base e and base 10. To do base 10, it's going to be a common log. And we're going to do our outer number right here over our inner number right here. So for base 10, it becomes log of 19,683 divided by log of 3. The reason why we pick common log because it's a button on your calculator. When you type that in, you would get 9. Now, if I ask you to do it in base E, the only thing that changes is my log becomes ln because log base e is your natural log. So that would be ln of 19683 or 19,683 divided by ln of 3, which is still 9. They both will yield the same answer. The key to when you do change of base is that whatever base you pick on top, it must be the same base on the bottom. Base on top, same on the bottom, and just remember outer over inner. Then you won't have any problems with change of base.